Hello, we are Bionet, and today we are excited to present our multimodal biometric capturing and matching device. Did you know that according to a study conducted by the Department of Homeland Security in 2018, 3 airports employed a prototype biometric security system that was able to catch approximately 250 more instances of passport fraud and identity theft in an average month compared to the traditional system based on human validation alone? This demonstrates the need for more advanced security methods that are more efficient and timely than current methods in use, as fraudsters become more adept at imitating government-regulated documents.
The Transportation Security Administration is well aware of this issue and has developed an 8-year plan to integrate this technology into American airports. They plan to contract out the development of a full end-to-end biometric matching system that utilizes the infrastructure that already exists within the Department of Homeland Security. The amount of flyers is projected to reach 2.5 million per day by 2026. The goal is to have this e-passport system service these 2.5 million daily flyers. Biometric data is intrinsically unique and therefore allows easy identification of a person. This approach provides a reliable authentication key that is very difficult for others to imitate. Bionet aims to produce a full biometric matching system capable of onboarding biometric data from travelers, including face, iris, and fingerprints. The system will securely communicate with government-regulated databases, allowing for one-to-one matching on a multimodal scheme. The device will be lightweight and handheld for easy mobility and accessibility at the point of use.
Introducing Bionet's Biometric Multimodal Device, a combined 3-part product that involves a biometric embedded system, an intuitive Android application, and a cloud infrastructure to support scalable deployment. The combination of this 3-part system results in a final product that can seamlessly integrate with existing government databases and acquire citizens' personal and biometric information for both onboarding and matching. The system itself is intricate and demands connections between the cloud infrastructure, the Android application, and the sensors and power system. The Android application acts as the heart of the system, communicating with both the cloud services and the Arduino. All 3 portions of the system architecture are shown here. As the heart of the system, the Android application dictates what is happening at all times. All commands are sent to either the Arduino controlling the hardware components or encrypted and sent through an API gateway that sends the REST calls to the appropriate cloud service. The commands sent to the Arduino do not need to be encrypted as they are through a wired connection. For the hardware side, the Arduino communicates with either the fingerprint sensor or the iris sensor over a serial interface, depending on the commands sent by the Android. In return, the data from the images are sent to the Arduino and relayed to the Android over USB to be saved and encrypted locally, and once again relayed to the cloud for secure storage. Additionally, there is a power delivery system consisting of a lithium battery and accompanying electronics used to charge the phone and power the rest of the system. The cloud services are divided into 3 subsections. First, we have the cloud storage. The information taken from the application during the onboarding flow can be split into personal information and biometric information, each stored in a different cloud service. Second, we have the cloud computations. These include the following. For user authentication, it must be verified against a database of credible users. For onboarding, a profile must be created to be securely held in the cloud storage. And for matching, which gathers the information from the matching flow on the application to be compared to what is stored in the user's profile. This matching is done in the 3rd subsection, the EC2 server, which holds the machine learning model for facial matching and math model for iris matching. The integration of all these system components allow for a timely onboarding or matching process when administered by the agent.
Bionet can be summarized in 3 key advantages: simplicity, scalability, and security. In terms of simplicity, our system is Android-based, meaning it can be used on any Android device. With a use case-driven UI, our system is simple and intuitive to use and requires little to no training. And finally, the device's portability allows it to be used in a variety of environments with ease. In order to service government bodies, scalability is key. Being cloud-driven allows for multi-user, real-time use across the country. This architecture also allows for easy integration into the pre-existing HEART database, which is the government-regulated biometric storage system. And finally, our system follows the Electronic Biometric Transmission Specification, or EBTS, which is the FBI-created security biometric standard. Security is paramount to ensure the safety and trust of our clients whose information we are using for biometric storage. Our system uses the Advanced Encryption Standard, or AES, which complies with government regulations. By leveraging Android security, our system takes advantage of onboard device security features. And finally, by being a multimodal system, our system has multiple layers of biometric authentication and validation. There are currently three major competitors for Bionet, none of which perfectly satisfy all of the stringent requirements set by the TSA. BioSled, which held a contract with NATO, fails to include end-to-end integration as they do not have a cloud system. Additionally, they had a very high contract cost. eGate is another competitor deployed in select airports across Europe. However, the system is immobile, meaning it can't be used outside of predefined checkpoints. Additionally, there is no iris scanning on the system, meaning it does not meet the trimodal biometric specification requirements set by the TSA. Lastly, Biometric Terminal H5. Though a cost-effective mobile solution, it lacks facial recognition capabilities and offers no support for connecting to external government databases. In contrast, Bionet is a cost-effective mobile solution, which offers trimodal biometric capture and matching, as well as a full end-to-end system capable of integrating into current American database systems. Now onto the demo of the product prototype. In the following video, we see our traveler going through the onboarding process. Their personal data is captured as well as their biometrics, and all this information is encrypted and stored in cloud storage for future use. Also shown is the matching sequence, where new biometric data is captured and compared against previously stored data to allow for one-to-one traveler authentication.
Here, we have the onboarding flow to add a new user to the system. To begin the onboarding flow, the agent logs in and is authenticated by the database using his credentials. The agent then selects Add Single Scan to onboard only one user. The agent then asks the traveler for their first and last name, with a possible middle initial, their date of birth, and their passport ID. The passport ID is unique to all users, allowing the system to know what to match for in the matching flow. Continuing with the personal information segment of the onboarding process, the street address, unit number, city, postal code, province or state, and country is asked and then inputted by the agent. All the personal information is stored in the DynamoDB database on AWS and is linked with that user. This concludes the personal information onboarding segment. The biometric information portion then begins as a photo of the traveler's face is then taken by the agent. There, the agent has the ability to retake the image or confirm and move to the next step. Here, the agent records the traveler's fingerprint for both the right and left thumbs. The fingerprint needs 3 placements of the thumb for an accurate biometric reading, and the app lets the traveler know what to do. The final step in recording biometrics are the irises. The agent records both the left and right irises of the traveler and processes them to send to the cloud for storage. Once again, as with the facial scan, the agent has the option to either retake the image or confirm it for each iris scan. The information taken during the onboarding process, both personal and biometric, is encrypted using AES before being sent to the cloud. This is for added security for all of our users. Once all the information is recorded by the agent, all that's needed is to confirm and upload the data. Here, we have the matching flow, where a traveler will attempt to be matched with the biometric information stored in the system. The agent begins by asking and inputting the traveler's passport ID, as it is a unique identifier of who that person is. Then, certain biometric matchings are selected. For the facial matching, a photo is taken as it was done during the onboarding flow. For the fingerprint matching, the proper finger, depending on what was selected previously, is placed on the sensor once and scanned to be matched with the traveler's already stored fingerprint. For the iris matching, the photo is taken as it was during the onboarding process. Once again, the option of retaking the image is provided if the image is of poor quality, mimicking the process followed in the onboarding flow. This would close out the biometric information gathering for the matching process. As with the onboarding flow, once again, all biometric information gathered is encrypted before being sent to the cloud where the matching is run. The biometric information is stored in EBTS format, a specified biometric information format that is used by the FBI. With all 3 biometric images captured, the matching process can then be done to either give a valid or invalid match.
So there was a vision that was said in the TSA governing doc by David Pekoske, who is the current TSA administrator. And he envisions a biometrics capability that is built with strategic partners, that enhances aviation security, streamlines operations, and simplifies the overall user experience. This vision actually encapsulates what we're trying to do as a team, because there were 2 priorities that we had when building Bionet, which was one was having security, because we're obviously handling very sensitive data. And secondly, we wanted our product to be very easy to use. So we actually did a case study to see how much a device would cost if deployed at scale. In 2019, LAX was processing around 10,000 passengers per hour. With our device, we estimate we can do 40 matches per hour. So dividing these 2 numbers, we would need around 275 devices. Each device costs $370. So the total cost for all the devices would be a little over $100,000. But we can't forget about other costs associated with this device, such as the cloud service fees. Remember, we're using many different AWS services. We're using S3 for file storage. We're using DynamoDB for other information storage. We're using servers to host our matching models. We're also using serverless endpoints for other functionality as well. So with AWS pricing, we estimate we would need to spend $86,000 annually to host our cloud services for this passenger rate. But keep in mind, this number is an estimate, because the beauty of cloud services is something called active scaling, which means that services will be undeployed, deployed, based on how much load there is in the system. There are a couple of things that can be done in the future to improve the overall device. So some future steps involve improving the overall iris speed in order to improve the experience from curb to gate for passengers. Secondly, we think creating a custom printed circuit board would also be very beneficial, because it will lead to other improvements, such as reducing the overall footprint of the device. A feature that we think should be added in the future, which would also benefit other stakeholders, would be something called one-to-N matching. So at the moment, we do something called one-to-one matching. So one-to-one matching involves comparing a person against themselves, right, to see if they are who they say they are. But one-to-N matching is comparing a person against a group of people. This problem is a lot harder to solve, but in the future, we think it will be a good feature to add. Another thing that we think can be done is improving the overall power system to make the device last longer. And in terms of the biometrics capability side, we think the device can also be improved to capture more biometrics, such as doing a double iris scan or doing things like a rolled thumbprints. With Bionet, our goal is to provide security with our biometric device. With the installation of our multimodal biometric matching device inside airports, we ensure that there will be less cases of identity fraud, making travel safer for passengers. I hope with this presentation, we've portrayed how biometrics can be useful in processes like the TSA. And with that, I would like to say thank you for listening and hope you have a nice day.